I'm going to show you maybe the first physics demo I ever made, ever. And it's this, it's a Cartesian diver. So if you look at this, you can see there's a floaty thing in this bottle. It's a soda bottle. And watch what happens when I squeeze the bottle. When I squeeze the bottle, it goes down. If I squeeze it just right, I can make it hover right there in the middle. This is called a Cartesian diver. Let me explain to you how it works, and then I'm going to build a couple versions of that. I already have one working, so even if it doesn't balance, you see that it does work. Okay, so imagine that I have some water. Water floats in water, right? So if I have this volume of water, it has a weight that pulls it down, it has a buoyancy force pushing up, but those two have to be equal because that water just stays right there. Now, suppose I replace that ball of water with some object. It could be anything. The water around is going to interact with it in the same way, so it should have, if it has the same volume, it have the same upward buoyancy force. Now, it may have a greater downward buoyancy force, and it would sink, or a lower force, and it would rise. It doesn't matter. The buoyancy force depends on the volume. Now let's take something like this. This is an upside down cup, and it has air in it. It also has glass around it or something. It doesn't really matter. But there's a weight on this that pulls it down. I can change the buoyancy force if I change the volume of air. Well, how do I change the volume of air? Well, if you compress air, if you increase pressure, the air gets smaller. So if I increase the pressure, the air gets smaller and the buoyancy force decreases. That's what's happening here. As I squeeze the bottle, since it's got a top on it, I'm actually increasing the pressure inside of it. That means the pressure in the whole thing is changing. And this device, the Cartesian diver, has an airspace in there. So when I squeeze that, that decreases the volume of the air and decreases the buoyancy force. And then I can just squeeze harder or less to make it go up or down. Okay, how do you make that version? So you need a bottle with a lid on it, okay? Fill it with water almost all the way to the top. Now the easiest thing to do is to take a straw. I'm gonna take the straw and I'm gonna cut it. And about yay long, 1 yay, okay, like that. And then I'm going to, if you put it in the water, the air is not gonna stay. So I'm gonna fold it over and make a bend like that. And then in order to keep it staying bent, I'm gonna take a paper clip and I'm gonna stick one end into one part of the straw and then bend the other end, and then I have a paper clip like that, see? Now I need to test it, right? If I put it in there and if it doesn't float very well, then this is not gonna work. So I have my little tester here. So I can put this in here, and what I want it to do is to float, not sink, but barely float. So see that one, it just topped over. It didn't float at all very well at all. So I'm gonna take a paper clip and add to the paper clip. So now I'm increasing the mass. I'm actually increasing the buoyancy too, but not that much because the volume of the paper clip is very small. Put it in there and still floats a little too much. Now I'm gonna put another paper clip. See, you just keep doing this. Now I'm gonna show you a trick. Yeah, I can't see. So bend the paper clip on there like that. Okay. Now I have total of 3 paper clips. Put it in there. That actually looks pretty good. If you can see, it's barely sticking. This one right here, it's barely sticking up above the thing. That will probably work. You put that in there, boom, done. Okay. If you put it in there and you squeeze and squeeze and squeeze and won't go down, then just re-weight it. Now another thing I can do, I use these. This one, I'm gonna take it out, which is always dangerous because you never know if you're gonna get it to work again. If you can't get these out, you can use a magnet, pull it up. This one, this large paper clip, I just cut part of the paper clip off until it was floating just right the way I liked it. This is a glass eyedropper. You can use this too. So first I want to fill it with some water, right? Like that, maybe a little bit more. And I'm gonna put it in my tester. And it looks like it's floating pretty well. Okay, so now let's put it in here and see if that floats. Okay, it might, so you can see the air in that one really nice, I like it. Put the top on, let's see if it's gonna sink. Now I'm gonna squeeze it. I like that because you can see the air. You can see the volume of air getting smaller as I squeeze it. So I'm gonna squeeze it. See that? Isn't that nice? That one looks really good. I'm excited. Cartesian diver. It's actually kind of fun to play with. Let's make one more. I might cut this out if it doesn't work. I wanted to make one with a balloon and a light inside of it. I thought that'd be kind of fun. So let's just try it. So here I have my my button cell light, and I had an LED right here. So I'm going to put this light, I'm going to tape it on, and then I'm going to put it in the balloon so you can see the balloon. I fully accept that this might not work, and yet I'm doing it anyway. Now, if you haven't done these button cell lights before, make sure that the plus goes to the plus side or it won't work. So there's my light. Now it should stay on. Now if I can fit this in, this is a bad idea. I should have stopped. But you know what? I'm not going to stop now. Stick this in there. You'd think it'd be easy. Go. Almost. Okay. You can't really see it glowing that much. That's fine. Now, I have some air in there. I don't want to put too much air because I want it to be able to stuff in there. So I'm just going to tie this tight with a paper clip. I thought that'd be fun. Put the paper clip through there. This is a bad idea. This is just a bad idea. It's not, I didn't even bring enough weights to weight it down. Okay, that's on there. So now let's tie it. Tie the balloon. I bet I'm gonna turn off the light or something dumb like that. Okay, there. Now I have the light, and of course it's gonna float way too much. Not too bad. Let's just put a bunch of paper clips on there and see if we can get this to almost sink. 1, I'm gonna put 3 on there. 2, 3. I think I need more. I think I need like a nut or something, some type of mass. Let me see what I have. Oh, here's some more paper clips. Let's put more paper clips on. More paper clips. Let's just put as many of these as we can think of. Paper clip. I told you this is a bad idea. I was trying to prove myself right that it was a bad idea. Okay, so it's hitting the bottom now. I think I'm gonna try it. Don't work, it doesn't work. Okay, so, and then the light's not even on, is it? No, it is. So let's get this thing out. That one's really good, I like that one. Put this one in with my paper clips. Stuff it in there. It doesn't want to go. Okay. Oh, it sank. Okay, well, let's just try to see if we can make it sink more. I put too many on there, surprisingly. Okay, let's just see if I squeeze this and it goes down even more, then that's still a win. Okay, I think it can work. I think it could work. It's moving down a little bit. You can see the balloon is getting smaller as I squeeze, which is kind of cool. Yeah, I think it'll work. But I want a brighter LED, so maybe I'll come back and do this later. I'm gonna keep this in there because I don't want to edit the video, but that's the Cartesian diver. You should build one, they're totally fun. I'll talk to you later.